Hello everybody, this is Michael. In this video, we will talk about the FPGA driver vibration sensor. Okay, so first things, let's take a look at our vibration module. So this is our vibration module, is this one. Okay, so is this one. Okay, so it has 3 pins. The first pin is control pin, is signal in. The second pin is the VCC power pin. The third pin is the ground pin. Okay, so this is our vibration sensor module. So here we will use the FPGA to control it. And how we control it? Usually we will use the PWM Wave to control it. So how we generate the PWM wave and in the FPGA. Okay, so first let's take a look at the wiki of the for the PWM wave. Okay, so for the PWM wave, this is the wiki. You can Google it. This is the PWM Wave wiki. So the very important things for the PWM wave is this one. Is the duty cycle. Okay. So how we generate the wave according to the different duty cycle. So this is 50% and this is 75% and this is 25% duty cycle. Okay, so next step, let's take a look at our code how to generate the PWM wave. And here is our code. Okay, so this is the top vibration top for this FPGA driver vibration sensor module. Okay, so here we will have a key in. The key is the touch key. We talked it in previous video. The touch key is here, is this thing. So this is the touch key. Is this touch key? Okay, we have one video especially for it. Okay, so we will have one key to control the PWM wave generate or not, and this is the LED out. We use the LED out to output the key signal to show the key is pressed or not. Okay, we just output the key signal to the LED to show the key pressed it or not. Okay, so this is a PWM wave generate to generate the PWM wave. Okay, the interface is clock, reset, key in, and PWM out. So this is the second 5. This is the second 5. This is PWM wave generate for our FPGA driver vibration sensor module. Okay, this is the input signal, clock, reset, and key, and PWM out signal. Okay, so this is the duty number. Okay, so why we set the duty number like this is 192, because we use 8-bit counter. Okay, this is 8-bit counter, and 8-bit it will be equal to 256. Okay, calculate the number will 256. If 25 duty, so our duty number will be 64. If 50% duty is half of it is 128. Each 128. If 75% duty, so it will be this number. Okay, increase by 64. Okay, so it will be this number. So I set the duty number is like this. Okay, so next will be the count increase. Okay, so we just here is reset. When the system is reset, we make it 0, and the other situation it increase by 1. Okay, so next step, PWM out signal. We will check the count number whether less than duty number or not. If it is less than duty number and also the key is pressed, okay, equal to 1. The touch key is pressed equal to 1. Then we output the PWM wave here, make it as 1. Otherwise, we make it as 0. So we output PWM wave. Okay. So this is a very simple PWM wave generate. Okay. It will generate the 75% duty PWM wave. Okay. So the next step, let's take a look at how the result. So here is the key. So make it here. I have a LED on the board. Is this one? I have LED on the board, and so if I press the touch key sensors behind the board, you will see here. If I press the touch key, the vibration sensor should vibrate, and the LED should be on, turn on. You see the LED is on. You will see the noise. The vibrate is already vibrate. The vibration sensor is vibrating. Okay. Okay. So if I move, the LED is off. Okay. The LED is off. Let's do it again. Okay. Okay, let's do it again. You will hear the sound, the vibration sound, and then remove, and then stop. And the touch is vibrating. LED is on. Remove. The LED is off, and the vibration is stop. Stop. Okay. Okay, so that's it. This is a very simple PWM wave driver vibration sensor in FPGA. Okay, I'm Michael. Thank you for your watching. See you next time.